Hi, my name is Uber Karthik, and this is my Lab 2 charge tapes revisited. For the purpose, it was to use charge tape to compare a point charge model to a line of charge model and their respective electric fields, electric forces, and the charge on each tape by dividing the tape pieces into small point charge segments and using superposition to add them up. For the preview, the magnitude of the gravitational force equals the magnitude of the electric force, which is about 2.09 E negative 3 newtons. The charge on each tape from Lab 1 was about 1.29 E negative 8 coulombs, and the charge on each tape from this lab was about 2.76 E negative 8 coulombs. For the fundamentals, I used the tape to model electric field of charge distribution along a line. I used the force of gravity, Fg equals mg, seen in the middle right. I used Newton's second law, F equals ma, seen at the top right, and Coulomb's law, seen at the bottom right, to calculate the charge on each piece of tape. And then I used the principle of superposition to find the total charge distributed across a piece of tape in my glow script model. So each tape that I used was modeled like small segments as point charges, with each of them having equal charge, and then I used superposition to add them all up. I assume that air resistance is negligible. Each segment and each whole piece of tape has the same charge as each other segment and each other whole piece, and the charge on each tape is equally distributed along the tape's length. From procedure, I define my system as 4 pieces of initially uncharged clear tape, and my surroundings as my bedroom and my desk with standard room temperature and humidity, no large external electric fields to disrupt the experiment. The procedure is listed as below. First, I folded tips of each tape underneath themselves to create handles. Then I stuck 2 base tapes on the desk, and then I stuck 2 upper tapes on top of the B tapes and ripped them off quickly to charge them. Then I stuck the ends of U-tape 1 to a raised platform to suspend it. In figure 4, U-tape 1 is U-tape B. Then I held U-tape 2 below U-tape 1. In figure 4, U-tape 2 is U-tape A, and then I observed the movement of U-tape B and recorded the distance between them. My data and calculations, I used the derived equations for the line of charge on the right, and then I rearranged this to find my Q and inputted Fg equals 2.09 times 10 to the negative 3 newtons, which is also equal to the electric force by Newton's second law. Using the recorded observations I have for the mass, the length, and the distance between the U-tapes, I calculated by hand that the charge was 2.615 E negative 8 coulombs. This was different from my glow script model because this was by hand and not using superposition. Here's my glow script code. On the left, we can see how the electric field and the line of charge is created, and on the right, we can see how all the arrows are created for the electric field and the electric force and the gravitational force. So for my first model through glow script, I used my old charge from Lab 1, and we can see that the white arrow is much smaller than the yellow arrow, and the white arrow in this represents the electric force, while the yellow arrow represents the gravitational force. And in our experiment, this is not possible. So with some trial and error, I was able to find that the charge on one piece of tape had to be 2.76487 E negative 8 coulombs for the magnitude of the electric force and the gravitational force to be equal. So some discrepancies in the model include that between this lab and last lab, I used a much more accurate model in this lab, and I broke up the model into finite segments, whereas the ideal model in real life would have infinite segments. Some sources of error include that the charge might not be equal on both U-tapes, the charge might not be evenly distributed along the U-tapes, there might be some mismeasurements from Lab 1, and there is possible electron transfer to the surface of the desk, the support system, my hands, or other nearby objects. So if I had modeled each of my tapes as a single point charge like the previous lab, my Q would be 1.29133 E negative 8 coulombs, and now my new Q is 2.76487 E negative 8 coulombs, and there is a 114.11% increase. These estimates differ because they use 2 different concepts of charge accumulation. In Lab 1, we assumed that the charge on the tape was a point charge, and now we assume that the charge is equally distributed along the line of the tape. Breaking this down into tiny segments and adding up their electric force in the y direction components by the principle of superposition, we are able to find a more precise approximation of the charge, and this is probably closer to the real value because in real life the charge would be distributed along the tape, not just clustered at one point.